It's a pleasure to welcome Tony Jakeman from ANU in Australia. Tony's professor in the Fenner School of Environment and Society, and as many of you know, Tony is really one of the early architects of conceptual rainfall runoff modeling, and it's a thrill to have him here. He's a good friend of Howard's and mine and many in the room. Tony's a fellow of the AGU, and he leads the Integrated Catchment Assessment and Management Center, his center at ANU. He's editor-in-chief of Socio-Environmental Systems Modeling, and probably the one person in the room whose jet lag can rival mine at this stage. So it's a pleasure to have Tony, and welcome.
Thank you very much, Jeff. Well, congratulations, Howard, on a stellar career, and I'm sure it'll continue in some new phase, perhaps in a reduced form. We look forward to seeing more of you. In the words of Sir Humphrey from Yes, Prime Minister show, you've done all right. Okay, so I'm going to move fairly fast because there's a big thread over there from a big man with a big stick. I'm going to move through a lot of slides, but basically the point I'm going to be making is that integrated assessment as a process has a lot to offer, and we need to do a lot more around uncertainty. So I'm going to contextualise the talk as well with some Australian experiences, just to make the point, but I think a lot of the points I'm trying to make are very general and apply worldwide. So we've got a fantastic water reform framework which depends on regulation, depends on markets, depends on water planning by communities. We've been quite successful with the markets particularly. We've got governance reforms where the feds and the states combine to manage things. And we've got a Bureau of Meteorology which for some years now has had a bigger role than just meteorology looking after hydrological information. Things aren't going so well though, even with such a great platform. Water reform is stalling, there's no new things really happening. We've got a lot of compliance issues now arising, people stealing water at big time. We've got perceived overinvestment in infrastructure rather than water buybacks for the environment, water allocation to the environment being the major problem. Our communities are uncertain out there in the regions, and the science is lagging. The ecology is very uncertain, the social impact assessments are very much wanting, and climate change is largely ignored, but perhaps that's not such a big issue because our climate variability is so high that kind of is factored in a way. We've got limited and superficial information available to the community, so not enough time is being taken to engage with communities, get information to them. And we're not really looking at innovations to see how we might manage water more efficiently, what new sources there might be, how we might do conjunctive use, for example. So we can't do much about the funds as scientists, but we do need funds for ongoing reform, both for science and for the institutions that manage our water. We need to deal with compliance, which requires more science around that. We need to manage the confusion and uncertainty, which means more engagement with our communities. And of course, we need interdisciplinarity. So we can do the sort of things Pat was talking about where we can start to look at risk under uncertainties and how we do our trade-offs between the environment, between social impacts, between economic impacts. Okay, so integrated assessment is a set of principles, if you like, which change under different contexts in terms of how they're implemented. But we do have a process there which will help guide us through looking into these issues and providing the scientific support that's needed. And you can see what that is there, and there's an actual society here which Claudia Parvossel, the next person speaking, has been very instrumental in setting up. But if we've got a problem, like in our case water allocation, then we've got to analyse and we go through various steps. And here are some steps that you go through, but in all of those phases, uncertainty arises. It's in the problem framing, it's in the conceptualisation of the problem, it's on the numerical aspects, it's on the communication and engagement. Uncertainty just doesn't enter in the model. To answer the first question that was posed, where are we in terms of integrated water resource management? Where have we got to? There's a bibliometric analysis a couple of my students, Fatim Zara and Takuya Iwanaga, undertook with me to look at the trend in integrated water assessment and modelling in the literature. And as you can see, the number of publications has been increasing substantially. And you can see there were 11 journals, this was through Scopus database, which show the increases there in the 11 major journals. You'll notice here we've got the key words listed in these articles, these 13,000 I should say, articles that were identified. And you'll see what's missing is, in terms of keywords, is uncertainty and the social aspects. And this happens whether you look at keywords, whether you look at titles in articles, those two things are missing. And then if you also look at abstracts too, then these words are missing. So we're not getting a lot of attention to the social aspects in these integrated modelling articles. If you look at the keywords, an overall percentage, you see that the socioeconomic is down at 13.6% compared to the other ones, which are nearly half each. And you'll see that basically of the overarching keywords, the main one that is there is management. If we look at the overarching keywords in the social, and this is the point I want to make from all this, is that, we do get a lot of attention on the economic side, but if you look at a lot of the other areas, the policy comes next, but if you like the stakeholder, the social, the areas of conflict, the law rate much, much lower. Okay, so let's return to the Murray-Darling Basin context. And the problem here we've got is how can we manage our water more effectively so we can improve yield, reliability, and multiple benefits of water, where those benefits are for the ecology, for the socio-economic impacts, particularly on local communities, but also for the economy generally. And also for the sustainability of our groundwater resource itself. So that's the big issue. So one of the things we're doing is, in a partnership with the Murray-Darling Basin Authority, is going into communities and in fairly large watersheds and exploring with them opportunities, taking a positive stance. So there's a lot of social sciences in this, which my colleague Alan Curtis leads, where we problem frame with the communities just what opportunities there might be for using water. We understand their problems. We do it around conjunctive use in this particular case, and we look at the feasibility of options in a qualitative sense, ranking different options under different criteria. But we also do the modelling because there's a lot of overlaps between and interconnections, and through component-based modelling and integrated modelling of the components, so that we can look at an assessment of the conjunctive water use opportunities. So this is very much a stakeholder-driven process where they come up with the ideas that we implement and test. And so it's bottom-up, it's using surface and looking at surface and groundwater, considers feedbacks, uncertainties, and it's very exploratory because we're doing lots of scenarios with respect to errors in the models, but also with respect to futures in terms of what the future might be done in terms of policy, but also climate change. Okay, so the innovations we elicited from the stakeholders, and that's the different irrigation groups, the local authorities, the state authorities and the feds, looking at managed aquifer recharge in a couple of different locations for that catchment, changing access rules for groundwater, giving them licences in the dry times, taking them back in the wet, looking at on-farm management options to use water more efficiently, and regional scale strategies too, which might mean piggybacking environmental flows with irrigation flows, but also maybe giving people groundwater licences where we don't want to take surface water to them because it'll evaporate and there's not enough of them to warrant that. Okay, so these are the sort of model outputs of this process that the different communities were interested in. So the productivity of their water resource, their reliability, sustainability, and different multiple benefits. And so we just develop indicators with them that we want to put out from the models under the different conditions. And here's just what the model looks like. So along the bottom, you've got the different outputs that they're interested in knowing the indices of, the quantified numbers. But you've also got the drivers up the top, the climate, the water policy, etc. And you've got all the links. So the big social aspect in this, in the modelling and representing it, is representing the policy, and it's also representing how farmers make decisions. Okay, so what we'll get out of this is that integration is a process that will deliver engagement. And we know this will happen from previous work and the enthusiasm that we have from the communities that we're working with. And we're using rich scenario ensembles, so they'll try to they'll get an understanding of what decisions might be taken under what risks. Okay. So with all this, there are opportunities for uncertainty analysis. So most of the current focus in hydrological modelling is really fairly sophisticated, deep stuff, you know, whether it's Bayesian Markov chain Monte Carlo modelling, etc. And what we need in this sort of area really is something that looks at not just the errors in the model, but just where uncertainty arises in the process, starting right at the problem framing and ending up in how you communicate your results and present them as well. So the way one needs to do the uncertainty will change with context, and it needs to be fairly eclectic. And we need to take qualitative methods into account as well. A thing that's not done but is starting to be done in the uncertainty quantification literature is looking at components of models and their uncertainties and looking at that as part of the whole. So decomposing the model into components and looking at their uncertainties and the linkages between them. And simpler methods we shouldn't be throwing away that work well, like sensitivity analysis, falsification tests, and running lots of ensembles to analyse uncertainties. Now, Pat Goeb is also involved in this succinct project we have with the University of Maryland. And what we're trying to do there is distill lessons that one has from undertaking integrated assessments, if you like, of different water resource problems. So the idea is that although every water resource problem is different, there is a set of questions you ask at each stage of the process. I showed you those 4 stages earlier in the talk. There's a set of questions you ask, and the answers depend on context. So you need to do a mapping to say, well, what practices do we undertake in a given context? And it's only by accumulating lots of experiences that we can provide guidance as to how that might happen, so that people don't have to learn from the beginning every time we get a new project, just have to go through all the sort of lessons that others are having to do at the moment. And we're using the notion of patterns that comes from architecture and more latterly computer science to say, well, a set of practices is a pattern in a given context, give it a name so you can actually remember it, or etc. And let's build up a database that does that. Okay, so finally, the main messages. Let's use stakeholder engagement and qualitative methods more often, and of course that's happening. But we must really put more emphasis on the qualitative. Look at research more on decomposition methods for uncertainty analysis of the different model components and how they link to the whole. Emphasise possibilities rather than probabilities. Don't make too many assumptions. Probably you won't be able to fit a probabilistic basis into all of this uncertainty issue. And factor in the costs of uncertainty assessment, which we don't do. And in fact, factor in the costs of engagement. One thing I haven't talked about, but we need more automated technologies to basically make our workflows more transparent, so that there's more trust generated through the process. So viewing models, therefore, as tools for engaging, generating trust, mediating, etc. And on this patterns idea, let's accumulate cases so we can start to identify patterns just as guides, not as recipes for how we might look at a particular water resource issue. So questions, thank you.